know, forests represent a key resource of mountain environments. Their valorization is hampered by accessibility constraints that prevent an efficient mapping, management, harvesting and transport of wood products. The available information is currently insufficient to provide at reasonable cost the required guarantees on the wood supply and on its sustainability. With the recent development of new remote sensing technologies and modeling tools, major improvements regarding the evaluation of the forest growing stocks and accessibility are now possible. Newfor is the acronym for New Technologies for a Better Mountain Forest Timber Mobilization. It is also an applied research project funded by the Interreg Alpine Space program. It brings together 14 institutes of 6 countries of the Alpine Space with the aim of improving forest timber evaluation and mobilization. The project considers the whole wood supply chain from forest to wood yards with a particular emphasis on new remote sensing technologies and geographical information systems. The main objective of the Newfor project is the improvement of mountain forest accessibility for a better efficiency of wood harvesting and transport in a context of sustainable forest management and wood industry in changing climate. In order to fulfill the Newfor objectives, the consortium of the project has defined 5 main actions or tasks. The first one is forest resources and LiDAR. The second key action of the project is dealing with forest accessibility. The third key action is forest and industry connectivity. The fourth key action is cost and benefits evaluation. The last key action is dealing with logistical planning strategy.
We mainly work with airborne laser scanning data for our analysis, and one of the main parameters we are interested in is stem volume, meaning how much forest is within the forest. For this we use a combined approach, using in situ measurements from the forest inventory, and we combine this with the airborne laser scanning data. Within the project Newfor, we did this for all pilot areas, which are distributed over the entire Alpine Space region. And the output is then a stem volume map for each of these pilot areas, which can then be used for further analysis, for example, to optimize some harvesting activities, or to use the stem volume map for forest management activities. In a second step, we are also interested how we can access this forest resource, meaning we have to know where is the forest road and how we can access each point in the forest. And for this we used and tested an algorithm to detect forest roads from airborne laser scanning data. We use the detailed DTM, so the terrain model, with a spatial resolution of 1 by 1 meter. And we use this in combination with orthophotos to extract the axis of the forest road, but also the width and the radius of the curves. Yeah, and at the end this is a good input for routing activities, for example for tracks that catch the forest from the forest, and we can use this road network for routing activities.
The laser scan is lasts a long time to prepare, and it's expensive. You need a manned aerial vehicle, and here you can go with this little plane and catch images, and so the aim is to find out if we can get the same quality of data like with laser scan data.
Basically there are different types of planes you can use for aerial photography. There are the multicopters, the helicopters and the normal planes. And the normal planes have the big advantage that they can cover a much bigger area because they are bigger and therefore it's easier to see them. And seeing is essential for steering because you always have to have the control over the plane.
We had a flight with a UAV, so we catched a lot of images. It was about 1,000 images. So we downloaded these images to the computer and have a look at it. And afterwards we will stitch the images together, so we get a 3D model of the terrain. This data you can export as a three-dimensional point cloud. We can compare it to ALS data from a laser scan.
This is an example of one of the results that we can get with the tools developed within the Newfor project for LiDAR data processing. Here is the initial data that we can have. This is, for example, here the topographic map. Then we have the aerial ortho photography. The same things but with infrared color. This is quite interesting because we can distinguish different species within the forest stands. The first information that we have with the LiDAR data is the elevation model. It means that this is the information on the top of all the obstacles. The second data that we can easily have is the digital terrain model. This is not the elevation on the top of the obstacle but on the floor. And then with this we can do few processing. One of the most common is to do a shading to have an overview on the reality of the topographic information that we can get with the LiDAR data. Here for example we can see easily a forest road over there. Here there is a river, and in this place there is a road here, and here is passing through a small village. We can do the calculation of the contour line. Here is with an equidistance of 5 meters between each of the contour line. And also what is quite interesting for us is to do the difference between the elevation model and the terrain model. And by making the difference of these two raster files, then we can have what is called the crown canopy model. This map is very important because here we can do the calculation of the volume of each stems because we are knowing the height of the trees and its diameter. Then it's quite easy to have a good evaluation of the volume of each of the stems. After the identification of forest resources, the second step of an efficient forest management is to evaluate the accessibility of these resources. In mountain area, topography is the main constraint to a technical and economically efficient harvesting.
After we have information about the forest resources, that means information about the stock of the stands or about the tree species composition, we have to think about how to get the wood from this forest. That means which harvesting techniques I use to get the wood. And so, in this work package, we asked our partners to tell us which harvesting techniques are applied in the country. We summarized these informations in a short overview. Of course, the harvesting techniques depends on the stock of stands and tree composition, but also on the area. That means the topography of the area. Is it a slope or not a slope? When you want to get wood from the forest, you need an opening up of the forest. That means you need forest roads, skidding lines and drain lines. Not all about in the Alpine Space where the forests are opening up. And so we try to develop a tool which can automatically mapping lines for forest roads and cable lines and skidding lines. You can do this with a computer. That means in your office. You need some tools like elevation model. When you have modeling, you're opening up of a forest. Of course, you have to verify this model outside in the forest.
The project has demonstrated how to use topographic LiDAR data in geographic information system for an optimal planning of forest harvesting and logging, while taking current and scheduled accessibility of forest resources into account.
280.
Yeah. Devo vedere la scritta più grande. Ma non fai un po'.
40 meters. 1, 4, 3.
Once the forest resources and accessibility are characterized, then remains the issue of the connectivity between wood piles in the forest and wood yard of mills.
This work package is dealing with wood transport optimization. Why are we interested by this topic? It's because wood transport is representing very high cost in the total wood procurement chain. The main reason explaining why the costs are quite high is perhaps three main reasons. The first one is that transport companies are using very specific equipment, so that most of the time it's not easy or it's impossible to find back haulage, so that you can make a whole turn with, of course, wood. The second reason is that it's not possible to work all the year round, because of course you have the winter, which make it difficult to go to the stockpile in the forest, and you have also a lot of wet period where it is impossible to reach the forest. Perhaps a third reason is that transporting wood in a mountain area is difficult because the access to the pile is difficult because of the forest road network, which is not very dense. So what are we doing in the work package 6? First of all, we have done a state of the art, and we have described the organization of each partner country, so that we have all a good understanding of what how is organized the transport in each country. So in terms of course, organization, who is doing what? Is it the sawmills who are giving the order, or is it some kind of forest service? So who is doing what? And also what kind of material is used, what kind of product are transported. So this was very important to make this first step, because the situations are very different from one country to another one. The second step was to study what are the available tools on the market to optimize wood transportation. So there was a big effort on the forest road database. Of course, this is an important tool if you want to make a route guidance system, to have the knowledge of the forest road network. So this was a first step. And the second one was to identify optimization tool. So this is tools that are able to make planification of the tours, so that you can improve the rate of utilization. This kind of tool can be used by three kinds of actors. This can be an association of transporters or an association of mills. This can be a big transport company or a big sawmill, by example, or a big pulp mill.
One of the deliverables of this work package has been the production of different maps. Here is an example of such maps for the Tyrolean Regional Forest Network area on which the tools Navlog have been tested. All the black points represent some specific black nodes on this network, which could be an obstacle to the flow of the traffic on such forest road networks. Such map is very important because it will help decision makers in forestry management to define where they can get out the wood from the forest and which roads they have to use to bring the timber production up to the wood industries like sawmills and so on. The fourth key action is cost and benefits evaluation.
It's a very big challenge to get the productivity in this steep terrain. It's everywhere a little bit other conditions, and we have not the same conditions in different regions, and so it's not easy to get a good tool to estimate this. In work package 7 we have a lot of colleagues from French, from Italy, from Slovenia, from Switzerland, and we are thinking about how to get good tools to estimate the costs and the benefits of harvesting projects. And we tried to find actually used web-based tools in this frame. We found some tools that we thought that they could be useful. One is Hepromo from the Swiss WSL, and the second tool we improved especially is from BFV 700 machines. It's a database with a lot of data and costs for forestry equipment, and we evaluated and improved these tools in more than 7 or 8 test regions in all countries with participating on this work package. We decided that the machinery database would work very well, and we started to actualize this database and to translate it to English.
One of the work packages of the Newfor project is dedicated to the communication and diffusion of all the results of the project. For this, the consortium has developed an internet website on which people can find the description of the project. There is a specific folder for this. There is the presentation of the different study area with, for example, you can see the map on the localization. This is one example for one of the Austrian pilot area, and also there is the presentation of the main activities of the project. You will find on the website the different actions that have been done within these different activities, and also there is a folder dealing with the news. In this folder you can find information about the project life, events, conferences and publication. On the publication folder you can find information about, for example, TV interview. You can find information about production within newspaper dealing with the project, and also you can find, for example, here articles that have been published, and you can download the PDF version. Here, for example, there is a downloading of an article that we have made in a European project magazine, and you will find information dealing with all the project information. You will find also specific links to other Alpine Space projects related to the same subject, and also by the end of the project there will be a specific folder on which you will be able to download all the different tools that have been developed within the project. The last key action is dealing with logistical planning strategy.
And to plan for the next period and for the last results of the project dealing with the OPA. So, as the
WebGIS integrating different tools developed in the project has been implemented and will be available for the stakeholders of the project. The key point is to provide the end users, such as forest manager, forest enterprises and the decision makers, with reliable information for the evaluation of technical and economical constraints, providing alternatives, strategies and solutions. Very important is therefore the dissemination of the result of the project to the stakeholder during the workshops and the summer school to the students coming from all the countries of the Alpine Space region.